Hello, and thank you for attending today's webinar, Onboarding Clinical Data Feeds, Strategies and Tools for Streamlining Connections and Increasing Accuracy, presented by InterSystems and Fierce Healthcare. My name is Janelle Karimoto, and I will be moderating this webinar. Before we get started, here are a few housekeeping notes. Additional resources can be found on the handouts window. You can adjust the size of each window on your screen, and if you accidentally close a window, you can reopen it by clicking its name in the top navigation bar. This webinar is being recorded and will be available on demand within 24 hours. And finally, feel free to submit your questions at any time using the Submit Questions window. It is now my pleasure to introduce the following speakers from InterSystems. We have Stephen Burko, Senior Advisor, Value-Based Care, Aya Heshmat, Product Manager, Data Quality, and Jim Powers, Program Manager, Health Information Exchange. And with that, I will kick it over to Stephen.
Hi, thank you, Janelle. And I also want to thank everybody on the line for making time to explore what's possible when you start to rethink how to onboard clinical data feeds. Now, if you have people at your organization who are wondering or don't appreciate why this is so important, I really encourage you to share the cartoon on the next slide. I trust a number of you can relate to that horse. It seems that everybody wants to talk about the possibilities of generative AI and agentic AI. And the not so hidden secret, of course, is it takes massive amounts of clean, machine readable data to power generative AI. I actually like to cite a pretty recent academic article on this topic because it just lays it out so crisply. I'm just reading on the right, just quoting from the article. It is now accepted that the AI and big data revolution will profoundly transform medical practice, care, and health research. However, to learn, function, and improve, AI algorithms and models need to be fed with massive quantities of data that are as structured as possible and of high quality. And it is urgent that this data pool be made available because most of the time, hospital data, clinical data, are very heterogeneous, unstructured, and produced at different scales. So not surprisingly, when we cross over to the industry sector or the commercial sector, look what's the top Informatech targets top 10 challenges for big data analytics and AI in the coming year. Now, for those of you who are not familiar with Informatech target, we've definitely crossed over from academia to what's going on real time in our industry. You can see they're a global partner helping B2B brands set up and accelerate growth. And what they do is they leverage insights from over 750 experts at 220 plus digital properties. And moving over to the right, look what's atop their top 10. Capturing and cleaning. It is that onboarding again. That's what is, that hidden secret. Yes, and there's a typo there. That second column is actually items 5 through 10. But I could make this argument actually without even talking about AI. Consider for a second NCQA's move to digital HEDIS, and I'm going to go all the way over to the far right. Basically, NCQA has put a goal out there that by 2030, their HEDIS measures will be all digital, or more specifically, they'll be deploying DQM. So all their measures will be defined in code and all supplemental information. All the things that we do today via chart polls will be gone to actually document closure of those care gaps. You're going to have to increasingly rely on clinical data feeds. Now, the essential first step, and in effect supersizing our clinical digital asset, is ensuring that you have a robust or a comprehensive healthcare specific model for two reasons. First, we want to ensure that as we're doing this work, these precious clinical data streams that we're getting, that we're leaving no data elements on the cutting room floor because we don't have a place to put them. And remember, it's not just for the immediate purpose that you might get a new clinical data stream. You want to ensure that you're also, for lack of a better word, harvesting and storing elements that could be used for other applications. And that brings me to the second point. You want to be sure they're put in a place and structured that they're easily gettable for all these different applications. Now, this is an area that InterSystems has very, very well covered. For those of you who don't know InterSystems, we're a global leader in interoperability with special expertise in integrating clinical data. And we have built up a model that is healthcare specific over the last several decades, not theoretical, based on actual use cases. It's an extensible model. So the more and more clients we work with, the more and more fields we add, and I think resulting in a very pragmatic, comprehensive healthcare specific model. Now, we're going to give our contact information at the end. This is obviously something that we're very passionate about. And if you want more information on that, please reach out to any one of us. However, the purpose of the day was not to talk about clinical data models, but how to get information into these models more efficiently and more accurately. And that's really frames what we're going to be talking about. We've been spending a lot of time recently on building new tools to rethink the process. And I use that term rethink very, very deliberately. This is not, I mean, this is very much an industry-wide challenge. So when we look around the whole industry, we started to realize that even if we collected all the existing best practices and we put them all to bear, we would at best make incremental progress. So we really sat down and thought about how can we reimagine the onboarding process. And what we want to share with you is new tools that we've been developing that are either on the cusp of production or already in production. So in a moment, I'm going to hand over the presenter duties to my colleague, Aya Hashmat, who is a product manager here at InterSystems and has been neck deep in developing our CDA validator. And the thinking behind this is we can dramatically improve the process if we can more efficiently and automatically isolate gaps and problems in clinical data streams and address them before we begin the onboarding process. And then she's going to hand it over to my colleague, Jim Powers, who actually heads up our onboarding team here at InterSystems. So is very much living your reality day to day. And what he's going to talk about is how he is leveraging the economies of scale we bring to build a living library of pre-coded accelerators that can really speed up the clinical data stream onboarding process. So with that, I'm going to turn it over to my colleague, Aya.
Thank you, Stephen. So just to sort of preface the coming information, I'd like to briefly introduce CDA, or Clinical Data Architecture, which is really the backbone of clinical data exchange. The CDA documents are structured in XML format, and it's really how healthcare systems can understand and share patient data consistently. If you've ever wondered how your ER visit summary ended up at your PCP's office, while that's very rarely done today via fax, it's more than likely it was sent electronically by a generated CDA document. So these documents come in as templates, and they include sections like allergies and medications, and they follow a common standard to enable that true interoperability for our healthcare ecosystem so we can meaningfully communicate critical patient information. And so to understand structured documents like CDA, you also need to be aware of US CDI, which is US Core Data for Interoperability, or simply federally required data elements for healthcare data exchange. You give me one moment. You give me one moment. I had to just reconnect my headset there. And so US CDI is simply the federally required data elements for healthcare data exchange, such as sharing a document that has both patient first and last name. You'd think that's obvious, but there are actual requirements mandating quality exchanges with those types of rules. And so these required data elements as part of the newer US CDI rules are increasing the required number of elements and are also becoming more complex, like needing to include social determinants of health requirements like zip codes, and other SDOH data elements that are more complex to capture. And so in recent years, the CCDA implementation guides, CCDA, which means Consolidated CDA, which is a guide on how to share a combined document with multiple document templates. And so these implementation guides have been attempting to align the document standard with required data elements during the exchange of patient information through these documents. And so with newer updates comes many conformance challenges as systems may fall behind on these newer expectations that are changing. And automating validation of these documents becomes highly critical. And so USCDI is really just one problem area for document implementers or the document creators. I'll also refer them as content creators. And so these implementers face real-world data quality issues such as missing or incomplete clinical sections where a clinical section could be completely missing, which throws USCDI completely out the door. You also see inconsistent use of coded libraries between WOINT codes, NOMAD codes, RX norm. These are all code libraries that allow us to meaningfully communicate clinical concepts such as diagnoses and specific dosage requirements. And so if we're not speaking the same language, this really leads to data mismatches between these systems, and consumption of critical patient information becomes extremely complicated. We also see that many CDA documents still contain unstructured or simply poorly unorganized data, which also limits consumption or automatic consumption. And so you can tell that these inconsistencies can cause downstream problems for document consumers, which can also complicate reporting for care gap analysis for the care team, which would also delay care coordination and could also lead to loss of patient insights, decreasing overall care quality, not just decreasing data quality. And so without proper validation tooling, identifying these issues becomes manual, reactive to issues, and pretty resource intensive. And so here we have the soon to be released InterSystems CDA Validation Service, which helps to address these challenges with an automated and scalable validation tool. It supports multi-document validation, allowing sites to test large volumes of these documents efficiently. It's built for security and compliance with user-based access while adhering to the HL7 specifications, so those document templates that I mentioned. It's also designed for ease of use, providing a clear interface for uploading and reviewing those results in an easy-to-view dashboard. And so the content or the rules that are being applied to these documents goes beyond actual syntax. We're also evaluating the documents for clinical logic, cardinality of data elements, and content conformance to check for real-world data quality. And the idea is that this tool would enable faster feedback cycles between content or document creators and consumers, so we can improve overall interoperability readiness. And so in the next piece, I have a quick demo of our validator at its current state today.
Welcome to the InterSystems CDA Validation Service. Shown here is the home page of the service where you can view previously run batch validation results. What you're looking at is a result of the first run validation batch, which is labeled by you. And below that, you can see high-level results of that batch run. So within that validation run, there were 300 documents that were validated, and the number of rules that were passed and failed and their percentages, as well as the number and type of sections that were found across all your documents within that batch run. Below, you can see per document that was fed into the validator. If we select a document, you are shown the error view for that document, which only surfaces the failed rules for you to walk through and address. In this error view, it is also categorized by the sections that were found in that document. For example, within the encounter section, there were a number of failed rules In this example, there were entry text must be non-empty, meaning that data that was found in that entry text was either not found or not able to be extracted, which in this case, the data in that entry was not extractable by the system. If we move forward to the document view, you can see all the rules that were run across this document passed or failed, and also categorized by the sections. For example, if we take a look at the medication section, you can see at a high level that all the entries found in that section did pass as there were data, and that data was able to be consumed. You can view entry-level rules that were either passed or failed. In this medication entry, we can see that there were a few data variables that were not found in that entry. For example, the dose of that medication. The rules are broken down whether or not the data was made available in the document and whether or not it was extractable or consumable. Next, we have document tests, which checks for document structural integrity, so taking a look at the document itself and how well it is structured and able to be parsed. So this document in particular passes all section level rules. We also have schematron and the document validation for HL7 specification, both of which have passed. And if there are any processing errors, you can view them here, such as in the medication section that we were looking at, we see that there was a duplicate entry that had the same ID, which needs to be addressed. Next, we have the batch metrics view. And for batch metrics view, you're able to filter this table by selecting the section that you're interested in viewing the rules for. So if we take a look at the procedures section, which appears to have the most number of failed rules, might be interested in viewing the most failed rule for that section. You can filter for that here. So the most failed rule across the procedures section was the performing organization was made available where the data exists, which failed around 1,400 times, which gave an overall success rate of 0%. So this is something that you can send to the document creator as a required data element to be compliant with the HL7 specification and US CDI data elements. That is the CDA Validation Service. For more information, please reach out.
All right, so that was just a quick little demo. So this is really just the first release of the validator, but data quality never sleeps, and we want to enable interoperability for all and make it easier to reach for the content creators and consumers. Part of this roadmap for the tool includes extending validation to data profiling and transforming your document. So how do we really address data quality issues, and how do we do so in a meaningful and efficient way? You can't really fix every single document that comes through an interface. So how do we solve for that problem? Having customizable data dashboards before, during, and after document consumption becomes a first necessity to assess document health and promote insights for care gaps, like for data aggregators, such as QHINs or quality health information networks. And so the validator is just the initial piece of that puzzle to achieve those validated data streams. And we'll look at, what that next step might look like. And so I wanted to summarize quickly that poor data quality costs everyone, and not just financial costs. For health plans, provider organizations, and data aggregators, it leads to technical rework, development costs, reporting delays, missed care insights, and poor care quality. And so investing in data quality early on through validation, organizations can lower their costs, speed up interoperability, and improve outcomes across the entire ecosystem. And as I mentioned, a next critical piece for this process would be document transformation logic. And this would eventually look like a library of available document adjustments or transformations of the documents so that you can apply them before they go through a data feed, so that you know for sure that your document consumer can consume all the data within your document. And so with that idea, I think that's the perfect segue to Jim's presentation on the accelerator tooling that he will walk through. Thank you.
Great. Thanks, Aya. So we're going to talk a little bit today about some of the tools that my team has put together to help accelerate transformation and also to standardize the way that we do transformations to bring data into the system. This is an industry-wide struggle for all of us who interact with CDA on a regular basis, and InterSystems has decided to sort of jump in and try to lead us forward a little bit on this to make it a little easier and more efficient for everyone. We want to share some of that today with you. So we have a standard workflow, and even just putting a standard workflow in place has allowed us to become a little more efficient, right? And it probably looks consistent with what you do today if you're working in the industry. So we acquire the data, we analyze it through a tool like CDA Validation Service. Then we do some data profiling. So we look at what's in the content of this message or this document. Then we apply our transforms so that we can normalize it and bring it in a way that's harmonious with the other data in the system and doesn't create duplicates or do other things. And then we deliver that. So we get the data into the platform, and then we can share that wherever it needs to go. In our case, in the health information exchange world, that's into our platform for longitudinal records, so that we can collate and consume data from multiple sources for the same patient to provide a holistic view of the patient's medical record and clinical experiences. So when we dove in on this and we decided to take a look, we focused in really on 3 questions. We've been working on this for a couple of years. And those questions are, why do inbound feeds, particularly CDA, cost so much to implement? And that's across the industry. That doesn't matter what HIE you're interacting with, what EMR you're interacting with. This is just a complicated data model, and it's expensive. We looked at what can we do to reduce the lead time required before a feed's value can be realized? Why does it take so long to get these interfaces done? What are the struggles that we're dealing with? What are the people who are actually doing these day in and day out encountering that's causing it to take so much time, calendar time, to get these things done? And the third is, how can we empower our customers to become more effective and efficient? So how can we give you tools? What can we give you to make it so that you're able to get your strategic objectives done by getting data into the platform faster? All right. So when we zeroed in on that, the other challenges really tie back to the cost. Time is money. So what we looked at is some of the challenges we found, and we did some analysis with our customers and looked at some of the records that we have from the different efforts that we've had with our implementation partners to onboard feeds. And what we found is that there's a couple of core problems that we needed to solve. The first is that onboarding CDA documents requires too much bespoke coding. So when you bring in a CDA feed from one facility and one EMR, that you've done one interface, right? The next time you have another feed from the same EMR, it might be wildly different. And there's a bunch of different reasons for that. But it comes down to you tend to start with a known good transform if you have one, and then you have to adapt it for what's different about this implementation of X EMR versus the last one. And then as you do that, you find out that things that were done for the previous iteration of this EMR aren't in the data feed that you have. So now it's causing problems for that. So now you need to go back and re-engineer it to take out the pieces that you don't need from the known good transform. And at the end of the day, I think, personally, I've been through a lot of these integrations where I've arrived at the conclusion at the end of the day where it might have been faster to just start from scratch and write the transform itself. So we really wanted to jump in on that and see what we can do about making this so that we don't have to start from scratch or start from maybe a not quite good assumption that things are going to work just fine out of the box or with a known good transform. The second, and this ties into the first as well, is that it takes too much expertise to get these done. CDA is a complicated data model. XSLT is a complicated language, as is XPath. And you need to have a suite of skills that gives you not only some clinical expertise, but also all the technical expertise to be able to write these transforms in a way that's effective, to look for the right template ID and to be able to sort through and parse through the XML in order to make changes on the document level so that you can consume things or normalize data or do whatever you need to do with the document to get it to its final state. So we wanted to create a solution that required less less time from experts and more time from analysts to sort of move things from everything being a very intense project for a very technical resource to things that someone who maybe doesn't have as much experience with XML or CDA would be able to jump in and take their experience that they have working on older HL7 version 2 interfaces and apply that and be able to really pick up the gauntlet and run with it, pick up the ball and run with it for onboarding CDA. And the third major challenge, and I'm only mentioning it because we don't have as much control over these, are the outside constraints. And Aya touched on this a little bit. So we have inconsistent data quality from sources. There are still EMRs out there where they allow users to free text in, things like allergies. So when you look at a set of data from that facility, you find that there's 37 different ways that they've spelled no known allergies in their free text fields, right? And you have to figure out a way to mitigate all that. And those sort of things, they just take time to go through and to sort of work through, and it's the reality of the systems. We also see variable EMR profiles, as I mentioned earlier. You have two implementations of the same EMR that might be wildly different because as the EMR implementation team is going through and implementing the EMR, they're making changes based on the workflow on the clinical side, the actual patient workflow, and that is always reflected in the data that you receive. So if there are steps that are skipped because that, for example, a clinic is all self-pay, so they don't do some billing information. Well, now you have information that may be captured on that billing screen that's no longer captured, so it's missing in your data set, just as one example. And the third is really competing projects. So this ties into the expertise requirement as well, where your organization, you need to have your most seasoned people working on things that are value adding and growth oriented. And splitting their time between that and going back to do the 100th CDA integration is probably causing some frustration. I know it causes frustration for us, and we would really like to be able to focus the more innovation focused resources on doing more innovative work and to allow you to do that and to empower you to do that. So to do that, to answer these challenges, we created some tools that we call the accelerators. We have two. We have one for HL7 v2 and we have one for CDA. And the HL7 v2, we're not really going to talk too much about today, but if you'd like to hear more about it or if you'd like to talk to me about it, you can certainly reach out to me after the presentation. But for CDA, I'll talk a little bit about how we came together on this. And what we did is we reached out to some of our customers and we talked to them about what they had for experiences with their transformations. We asked them to share their transformations with us, and they did. And we put them through a fairly rigorous analysis project. And what we found was that across all of these hundreds of transforms, that corresponded back to about between 40 and 50 different EMRs. What we really found was that there were 27 core actions that were being done. These are things like normalizing units of measure for vital signs from metric to imperial, or completely suppressing a section because you don't want to ingest it. For example, medications. There's an HIE that doesn't ingest medications. They ingest information from a centralized PDMP source instead for their medication section within our HIE platform. But it really boiled down to 27. And when we saw that, we sort of realized that there is a big opportunity for us to change the game and to make things easier for our customers and hopefully eventually make things easier for the industry. So what we've created now is a structured workflow for transformation. So I mentioned earlier that we have a standard workflow where things sort of go through the same steps, but when we actually get into the process of creating a transform, we've got this process. And I have it expressed as an ETL here, just for familiarity. So our extract is how we receive the data. That could be over SFTP, it could be a flat file, it could be via IHE, it could be via a query out to a national network like eHealth Exchange or Commonwealth. We take that in. Once we have that data, we do some data profiling on it. So we need to understand, first we validate the structure, and then we validate the content. So we look at the content, we look for those places where you have no known allergies spelled a bunch of different ways, or other places where you have poor conformance to including codes, encoded value sections like laboratory results or other places, so that we know sort of where the trouble spots are for each document. And then we apply the accelerator. And the accelerator is a limited transform that normalizes the data and sort of takes care of those things that we find in data profiling so that we can pass it through a standard transform. And by splitting, rather than doing a transform from scratch to go from the CDA data model to our internal data model, we instead created a two-stage transform. So the first stage, which is where all the normalization from the wild to our local specification happens, is much smaller, which makes it easier to support and easier to troubleshoot. So again, we try to move that expert requirement a little bit away so an analyst can do the troubleshooting and see, is there something in the accelerator that might be causing this problem before we'll have to bring an expert in. And then after that, it all hands off to a standardized transformation that takes data into our data model. So we have a big full data model transform, but that full data model transform is no longer shifting interface to interface. It's staying consistent across, which again, helps to reduce the support burden and helps to reduce total cost of ownership over time. So that's sort of our philosophy. That's what we've integrated. And then of course, once that's all done, it gets loaded into the system. And what we found is that we broke this down and we stopped looking at it as transforms and we started looking at it as actions and profiles. And as we built these out and as we moved things over to the accelerator, what we found was that we were able to create a library of transformations. And so we can see for every different iteration, or every different time we've seen a different installation of the same EMR now, we can tell what settings have been turned on and what settings have not been turned on for that facility, as well as some basic configuration info so that we know and we can make a repeatable or an educated guess on what it's going to take to repeat that transform in the future, which really means we are able to reduce costs by having things be more predictable. And that's really the power of this. And this is something that we do make available to customers who are using our tooling upon request. And as you can see, there's tons of different interfaces and tons of different EMRs, and we've since grown the transformation library up significantly from where it started with those 27 core actions. And with every interface that we add, it becomes more robust. So when we talk about configuring the CDA accelerator, this is really the analyst view that I'm going to show you here. So this is inside our management platform. And as you can see, it's got a place for a drop-down list to select a profile. And for our purposes, a profile is a collection of actions. And underneath that, you have the actions that we've built into to the accelerator. And this list of actions is extensible. So you have your expert that I'll show their workflow on the next slide, who's able to extend this. And you have your analyst who's able to apply this. And the goal is to have your more senior resources collaborating with your less senior resources so that your less senior resources can get these interfaces done, but also to provide an on-ramp to expand and grow their knowledge so that they can eventually also work with XSLT and learn the CDA data model. So we sort of try to create a little ecosystem where we're building up your talent and helping your talent to become more proficient on the different data models and on the different things that are required. So behind the scenes, this is the expert view, right? We've got our drop-down list over here on the left, and you can see there's an Epic profile that's selected. You can see that there's different things like delete vaccine encounter as a checkbox. There's also a couple of things in here where we have a simple string put in that interacts with the different actions in the system that serve as parameters. And then on the right, what's actually happening behind the scenes. So behind the scenes, we have a fairly complicated XSLT that runs that is the accelerator. The profile determines which switches are turned on or turned off. So if we think about this from a biology perspective, right, the actions are sort of our chromosomes, and the profile turns on or off those chromosomes in order to express specific behaviors. So we're able to create one transform that's able to adapt to what it encounters in the wild and to grow. And that's really the core of what our long-term vision for this is. There's plenty of opportunity here down the road for potentials. Things like applying genetic algorithms to this to really try to test out and see what we've got for what's coming in versus what we know, so that we can try to make it even faster to do these transformations. So this is what we think is what the future might look like for transforming CDA. We do have the benefit with InterSystems that we are transforming to a static data model, which is SDA, which is our internal data model. But I think that this is something that could benefit everyone eventually. So let's talk a little bit about results, right? So what we found so far, and we've been at this for a couple of years, we've really been using the accelerators heavily for about a year now, is what we found is for HL7V2, we have realized a cost savings of up to 50% per interface, and we consistently hit that 50% right now. For CDA, which is a little more surprising to me, we've actually achieved up to 60%. And our goal is to reduce each by 80%. So if you think of CDA, a fairly standard industry number is 160 hours. We would like to get that down under 40 hours to be able to onboard an interface. And truth be told, if we can figure this out together, I would love to be able to take in a CDA interface and have a transform that you can build in an afternoon with an analyst. And I think that that's really where information exchange will become seamless enough to actually transcend to become more of a utility, I think, which is sort of the long-term goal for many of our customers. So that's it for the value, and that's actually it for my presentation. So on behalf of Steve and Aya, I just wanted to say thank you to everyone for attending today and giving us your time. I know it comes at a premium, and we appreciate you spending it with us. I think that I'm going to hand it over now to Janelle for some questions, and we'll take it from there. Thanks, everyone.
All right, Jim, thank you so much. And then Aya and Stephen, please join us back on screen. Audience, we've got some great questions in here already. Feel free to keep submitting questions as we're going through. We will get to as many as we can, and I will try not to do any duplicates, but please forgive me if I do. All right, let's kick this one off. It looks like this one is recently asked of you, Jim. You mentioned having built onboarding accelerators for HL7V2 as well. To what extent do they work differently or the same as your CCDA accelerators?
So the HL7 accelerators are a little bit older. They're sort of the precursor to what we built for CDA, and they work the same way. They go into our implementation pipeline the same way, but they're coded a little differently, and they're a little more hard coded. So it's a little tougher to extend them, but they are still extensible. And in a future version, we might look at refactoring it to unify it with the CDA structure.
Okay, next question. Who is the intended user for your accelerators? Will our business analysts be able to deploy, or will some coding still be needed?
So I think that as where we start is we start with by giving you the profiles that we have and the actions that we have, so that from the start, once we've been through the implementation process with you, you should be able to implement standard typical things. However, you do still need an expert to be able to extend the functionality of the accelerator. So you have that two-person role, that two-person team, where the analysts can do 80% of the work, and the expert might be required for 20% of the work. But we would eventually hope to see that diminish as the analyst becomes more proficient in using the accelerators and XSLT to be able to write for themselves.
Thank you. Next question. How much do you think FHIR will be a game changer with respect to onboarding? Do you have any sense yet of how fast or slow we'll see an industry-wide embrace of FHIR?
Well, I actually think it's going to increase the demand for what Jim and I have created. And that's because increasingly we are going to have everybody wanting to move stuff into FHIR. But the reality is there's a huge number of systems out there that are already built that speak a different language. So increasingly, we're going to be doing just as much, if not more, transformation. It's the output is going to be into FHIR, but I think it's going to be slow going in terms of changing the input. And I think the other thing that people have to realize, and I hate to be kind of the sad sack here, but what we're seeing out in the industry is there's still a good bit of variation in terms of FHIR. In effect, you have it's FHIR, but it's FHIR speaking different dialects. So we're also going to have to get used to the fact that we're going to have to be transforming one dialect of FHIR into another dialect. So I don't want to be negative, because it's great that increasingly we're all shooting towards a shared, common, interoperable standard. But we've got a lot of legacy systems out there that we're going to have to transforming into FHIR. I don't know, Jim, if you want to add anything to that.
No, I think you hit the nail on the head. Good.
Thank you. And Aya, this one came in while you were presenting. Have you seen any patterns in your data validator pilots? Are there any specific types of data streams, fields, or areas that are consistently problematic?
Yeah, we definitely started to see patterns across our pilots. I think the majority of issues cluster around a few areas: terminology alignment, the missing sections, structure and content mismatches. Like, we often see outdated LOINC and SNOMED codes, empty sections like allergies or immunizations that could technically pass through the document level rules, but cases where narrative text doesn't match where structured entries should be completed, it makes the document readable, however unusable for actual consumption. And so I think that's where our tool tends to pick up those rules related to whether or not data can be consumed, which is good and bad news, since those types of errors are not random, they're systemic, so we can fix them upstream. And ideally, all the other insights that we are seeing through the pilots will help us refine the validation rules and highlight more high-risk sections like lab results, the problem lists, and eventually move forward to more automated recommendations to help flag issues and resolve them through tools like the accelerator.
Yeah, I just want to, the devil is in the details. I think it's really cool that we're uncovering patterns. And so maybe there's more strategic approaches to this. But we are really trying to make it easier to find the needle in the haystack. So when you go to your content creator, you can be very, very specific. Hey, it's these 4 things. Everybody's incredibly busy. And I think if we're going to get our content creators to kind of make the necessary upstream changes that we need, the more specific we can be about exactly where to focus will be powerful. It's easier to solve very, very concrete problems.
All right, we have another question in here. Does CDA Accelerator come with pre-configured profiles for specific EHRs, or does each customer need to build their own?
So when we deploy out the CDA Accelerator, we do it with a small professional services engagement where we will install the tools. We will give you all of the actions that have been configured. We'll share the transformation library with you, and then we'll do one interface for you, one interface with you, and then you'll do one interface with our help. And by that point, our hope is that you'll be able to take over from there and continue to roll it forward. But yes, part of the whole plan for this is to make it so that we can share transforms across customers. I firmly believe that the problem of CDA and onboarding CDA and later FHIR into standard data models is something that's going to be crowdsourced, and that's one of my core principles for this. Great question.
Any last thoughts from any of the 3 of you? And I also noticed that we've got your emails available on the contact sheet. So if for any reason anybody wants to reach out to you after this, they can. As a reminder, recording of the session will be available on demand within 24 hours. Thank you for joining us all today, and we look forward to seeing you next time.
Thanks, everyone. Thanks for your time. And again,
I
think as we've alluded to all across, this is something we're very passionate about. And we're eager to talk to you if you think we can help. We're also eager to learn from you if you have ideas that you want to be sure that we bake into our development. So thanks again.